Okay, these are the notes over page 49 in your math journal over equivalent ratios. So we already know that the word equivalent means that they are going to be equal. And ratios are when we are comparing two different units, two different numbers, quantities. So we are going to be determining if two different ratios are equivalent or if they are equal. So here we have two different ratios. We have 3 to 2 and 36 to 24. So in order to determine if they are equivalent or not, there are two different ways that we are going to use to determine if they are equivalent or not. The first method is a scale factor. That should always be your number one go-to, is to determine if there is a scale factor. So we are going to rewrite our ratios as fractions because there are a couple different ways that you can write a ratio. One of them is with a colon and the other way is with a fraction. So we have 3 over 2, and if the 3 comes first, the 3 needs to come first in my fraction. It needs to be my numerator. And so since the 36 comes first in our second ratio, 36 needs to be in the numerator as well. So 36 over 24. So now I need to determine if these two ratios are equivalent. So I know that I can get from 3 to 36 by multiplying by 12. So our numerators have a scale factor of 12. Now if I look at my denominators, I know that I can get from 2 to 24 by multiplying by 12 as well. So both my numerator and my denominator have the same scale factor. So I know that these two ratios are equivalent. Like I said, that should always be your first go-to, is to determine, do you see a relationship between the two numbers? Now it's not just from numerator to numerator. You can also do a relationship between numerator and denominator. But in this case, I do not know, or we do not know, a whole number scale factor to get from 3 to 2. So the second way to determine if the ratios are equivalent are by using cross products. So I'm going to set up my ratios the same way, 3 over 2 and 36 24ths. And when using cross products, product means the answer to a multiplication problem. So we are going to multiply the numbers that are across from each other. So 2 times 36 equals 72. And then 24 times 3. That also equals 72. So when using cross products, I get the same answer. They both equal to 72. So those are the two different ways that we are going to determine if our ratios are equivalent or not. So we've got some practice problems down below, and all we're going to determine is, are they equivalent? So we want to know, do we have a common scale factor? And if not, we need to look at cross products, or if we don't have a whole number scale factor. So I know that I don't have a whole number when multiplying to get from 7 to 8. So I'm not going to go from numerator to denominator. But I know that if I go from 8 to 88, that's times 11. Now 7 times 11 is not 91. So these two are not equivalent. Okay? So now if I take a look at the second one, to get from 6 to 6, that one's easy. I can multiply times 1. So if I look here, 84 times 1 is 84. So yes, they are equivalent. So if I look here, 10 to 150 has a scale factor of 15. So 4 times 15, and it's okay if you're not sure. If you need to do on the side 15 times 4, it is 60. So they both have the same scale factor, so yes, they are equivalent. All right, so 3 to 21 has a scale factor of times 7, and then from 1 to 7 is a scale factor of 7 as well, so yes, they are equivalent. So all we're doing is finding these equivalent fractions. So if I were to just have 7 over 21 and ask to simplify it, I would get 1/3. So we're kind of doing the opposite of simplifying when looking for a scale factor. So if I have 4 to 4, that's times 1. 48 times 1 is not 40, so no. They are not equivalent. If I go from side to side, so 8 times 8 is 64, and 2 times 8 is 16. So yes, they are equivalent. Okay. Now I have 4 to 48 times 12. And 9 times 12 is not 72. 9 times 8 is 72. So no, they do not have a common scale factor, so they are not equivalent. 6 to 66 is times 11. Or if I went from 6 to 12, that's times 2. So I can look at it both ways. So 66 times 2 is 132. And 12 times 11 is 132. So yes, this one's equivalent as well. So all we're doing is looking for that relationship, if there is one, between two numbers. And if they do have a common relationship, then yes, they are equivalent. So now we've got some where we are missing a value, and we have to determine what the missing number that makes the ratio equivalent. So if I look, I know that 10 times 3 is 30. So what I do to my denominators, I have to do to my numerator. In order for it to be equivalent, we have to do the same thing to both the top and the bottom. So 5 times 3 is 15. So if we look over here, to get from 1 to 9 is times 9. So do the same thing to my denominator. So 9 times 9 is going to be 81. Okay. So now we have 4 times 9 is 32. So 8 times 9, sorry, 36, not 32. 8 times 9 is 72. Okay. Then if you look here, we could get from 4 to 8 by multiplying by 2, and 36 times 2 is 72. So we're just looking for that common scale factor. So now I can do 1 times 4 to get to 4, and then 5 times 4 to get to 20. So now 7 times 3 equals 21. Now see, this one's a little bit different. So in order to get from our missing value to 12, I would have to multiply something by 3. Sometimes we don't know what that is off the top of our head. But if we multiply by 3 to get from left to right, I can divide by 3 to go the other way. That might be a little bit easier of an option. So 21 divided by 3 is 7. So then 12 divided by 3 is 4. Okay? It is okay to use division. So 2 times 3 is 6. So 5 times 3 is 15. Okay? And that is the notes over page 49 over equivalent ratios.